Okay, we're up to page 9. We're still looking at restrictions on permutation questions. Okay, here's another general counting principle that's very helpful. Sometimes it is easier to deal with the complementary situation. Okay, just like questions in probability that say at least one blah 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 blah. Often it's easier to do one minus none. Same sort of thing applies for counting. So if it is easier to count the number of unacceptable offerings, then the number of acceptable orderings, is going to equal the total number of orderings minus the number of unacceptable orderings. Okay, so total minus the unacceptable. Look for keywords like not or at least, and they're a big prompt to use this method. So how many 7-letter words can be formed from the letters A, B, C, D, E, F, G if the vowels must be separated by at least one consonant? Okay, so the vowels. So how many vowels we got? We got A and E. We got 2 vowels and we got 5 consonants. Okay, so we got 2 vowels, 5 consonants. So we want the vowels to be separated by at least one consonant. So hopefully you can see that the complementary situation of the vowels being separated by at least one consonant would be the vowels separated by 0 consonants. Okay, so 0 consonants would mean that the 2 vowels are together. So what I'm going to do is I'm going to do the total minus the vowels together. 2 vowels together. That'll give me my answer. So the total number of arrangements, 7 letters, 7-letter words, 7 factorial, minus the 2 vowels together, you'd block them. Okay, so they can be arranged in 2 factorial ways, the 2 vowels, and then there's another 5 other groups. So that's 6 groups. So multiply by 6 factorial to arrange the groups. So that's the amount of arrangements with the 2 vowels together, minus 2 factorial times by 6 factorial. Okay, so into your calculator, you should get 3,600. So much easier than considering the cases, because you would have to consider one consonant between the 2 vowels. If you're doing cases, then next you'd have to consider what if there was 2 consonants between the 2 vowels, 3 consonants between the 2 vowels. So many cases, so this method is much simpler. Alright, now we're going to do a few random questions that are a little bit different. This first one here is very tricky, but we'll be able to do it. Let's do it. In how many ways can 2 blue covered books and 6 green covered books be arranged on a shelf? Arranged, permutation, order important, if there is at least 4 green books separating the blue books. So at least 4 green separating the blue, the 2 blue. And I've put note different titles, so each of the blue book isn't the same blue book. They're not. They're distinguished. And same with the 6 green books. They're all different green books. Okay, so I think the only way I can see to do it is by using cases. Let's start off. So separating the blue books, we got 4 green. Okay, so unlike the last one where we looked at the complement situation, I think it's better to just go for it in terms of normal cases, because we're almost there with 4 green in between. So we've got 4 green. If it's at least 4 green, there's 6 green altogether. So we've got to look at 4 green in between, 5 green in between, and 6 green in between. So 3 cases. So 4 in between. So let's block it. Let's group it. So we've got 2 blue books here, 2 factorial ways. Then we've got 1, 2, 3, 4 greens here. Now we've got 6 green possibles. So I've got 6 green books and I'm picking 4 to go in there. And then, now that's 6 books done. We've got 2 more books to go. That would cover all my books there. So therefore I've got 3 groups. Okay, so I'm going to times that by 3 factorial. Okay. When I get that, I get 4320. Okay, so that's that case. Second case, I'll call it case 2. 5 green in between. So we've got the 2 particular blues. 1, 2, 3, 4, 5 in between. So once again, 2 factorial ways of arranging the blues. There are 6 greens left, so 6 books left, and we're picking 5 spots. Okay, and then we'll have 1 other green book over here. So we've got 2 groups. So we're going to times that by 2 factorial. Okay, and when I do that, I get 2,880. In case number 3, 6 green in between. So we've got 2 blues, which we can arrange in 2 factorial ways, and then 6 green in between. 1, 2, 3, 4, 5, 6. 6 green books to fill 6 spots. So that's going to be 6p6 or 6 factorial. Okay. 6p6 or 6 factorial. And that's 1440 ways. So I'll finish it up here. The total amount of ways, 4320 plus the second case was 2880 plus 1440. Which is 8640. That's the answer. All right, next. 6 boys enter a boat in which there are 8 seats, 4 on the bow side and 4 on the stroke side. In how many ways can they be seated if there are no restrictions? Okay, what's interesting is that normally you've got a larger amount of people than spaces to fill. Okay, but here it's kind of like the opposite. There's more seats than people. So we need to kind of visualize it a little bit different. So what we're going to do is we're going to consider one boy at a time and consider how many seats that particular boy has got the option of taking. So 1, 2, 3, 4, 5, 6. I'm going to put the small amount of the 6 boys there. So normally this would be places, but what I'm going to do is I'm going to have this as boys. So boy 1, boy 2, boy 3, boy 4, boy 5, and boy 6. So let's imagine the first boy approaches the boat. How many seats has he got as options? He's got 8 options, right? The second boy approaches the boat. How many options for seats does he have? Well, he's got 1 less because boy 1's already taken up 1 seat. So he's got 7 options. Then this one would be 6 options. This would be 5. This would be 4. This would be 3. Okay, so that's 8. And we're picking how many spaces? 1, 2, 3, 4, 5, 6. Okay, so it's 8p6. Okay. And AP6 is 20,160. So that's the answer for A. Now we're going to have some restrictions. So 2 particular boys, A and B, want to be on the bow side, and Zeno wants to be on the stroke side. Remember, restrictions deal with first. So I'm going to call boy 1 Adnan. The second boy will be Brett, and then Zeno. So they're my 3 restricted, and then I've got three other boys to fill in after that. So how many options does A have? He wants to be on the bow side. There's 4 seats on the bow side, so A's got 4 options. B also Brett wants to be on the bow side as well. One of the bow side seats is already gone, so there'll be 3 seats on the bow side left. Okay, Zeno wants to be on the stroke side. No one yet's taken a seat on the stroke side, so there are 4 seats left on the stroke side. So Zeno's got 4 options. And then I've got 3 boys left. I've taken up 3 seats. So instead of having 8 seats on the boat left, we've got 5 seats on the boat left. So 5 options for the next boy, then 4, then 3. Okay. Okay, so plug that into your calculator and you'll get the answer. Didn't seem to do it. I'll do it quickly. 4 times 3 times 4 times 5 times 4 times 3. 2,880. Okay, last one here. Bit different. We've got 8 PR is equal to 336. Find the value of R. I'm going to show you 2 methods. Method number 1 is my preferred method. It's basically guess and check. Trial and error. We know that R has to go between 0 and n and has to be an integer. Okay, so it can be 0 all the way up to 8. Okay, so you can guess some values. If you use R is 3 in your calculator, you'll see that R equals 3 works. Okay, so 8p3 is indeed equal to 336. Okay, but let's imagine you want to do it algebraically using the definition of NPR. So NPR is n factorial over n minus r factorial. Okay, by the way, that formula is on the reference sheet. However, I recommend just to memorize it. It's an easy enough formula to memorize. So substituting in, we'll have 8 factorial. So we're replacing n by 8. 8 minus r factorial is equal to 336. Rearranging, 8 factorial over 336 is equal to 8 minus r factorial. Now I'm going to put this in my calculator. So put that into my calculator and I get 120 is equal to 8 minus r factorial. And now what I'm going to do is I'm going to make both sides in terms of factorial. So what factorial is 120? If you know your factorials by now, you'll know 5 factorial is 120. Okay, if not, you can guess and check in your calculator. So that means that the inside bits must be equal. So 5 is equal to 8 minus r. Bringing that across, r is equal to 8 minus 5, which is 3. Okay, a bit of work to do. Only question 19 and 20 from 6.3. And I want you to do the Cambridge 14B and 14C questions. Some nice challenging ones there. Have fun, and I'll see you in the next video.